Welcome back. We are simplifying algebraic fractions where we have 1a y plus 1 out of y square minus 1. So as you can see, we have our numerator y plus 1 and our denominator y square minus 1. So when a question says simplify, it means we have to make it look simple. The way it is complicated. So we need to make it look simple. So now what we need to do, we need to see where we have work to do between the numerator and the denominator. As you have seen, on the numerator, there's nothing that we can do as y plus 1, y and 1 are unlike terms, so we cannot add. Now, when you look at the denominator, y square minus 1, obviously also they are unlike terms, but there is a special expression called the difference of two squares. So when you look at the denominator, y square minus 1, this expression is a special one called the difference of two squares. Now, it is a difference of two squares because, as you can see, difference is in subtraction and we are subtracting squares. Y square is a square and of course 1 is a perfect square. So this is called a difference of two squares. You have a square on the left hand side and a square on the right hand side, and you have the difference which is in subtraction. So we need to work on this one. So as you proceed as follows. Of course, the numerator, there is nothing that you can do. You just copy it the way it is. Y plus 1 out of, now you can see this is a difference of two squares. So the way you factorize it, you say y minus 1 and y plus 1. So the whole lot of this expression now gets separated into y minus 1 and y plus 1. So once we do this, then we would have factorized this. You can see we have two ones here. We have negative 1 and positive 1. And we have y square and we have y here, y here. So the way you factorize a difference of two squares, you just copy the way it is without the square. Then make sure that you have a minus and a plus. Just copy one y here, another y there, and this. You just duplicate this one here and here, and also this y here and here. And also make sure that you have a minus and a plus. And you are done when you do this. Now, you can see between the numerator and the denominator, there is a common factor. You can see here we have y plus 1, and here we have y plus 1. So why not say y plus 1 into y plus 1 is 1, and y plus 1 into another y plus 1 on top here is 1. So that we shall have our numerator 1, this one here, and our denominator as y minus 1. So once we do this, then this question is done. So basically, this is how we simplify the difference of two squares in an algebraic fraction. Okay, so this is how we do this. Now let's look at our next example, 1b, where we have 1b, where we have x minus 1 out of x square minus 1. Okay, so again, when you look at this algebraic fraction, you will see that the numerator x minus 1, we can do nothing on the numerator. But on the denominator, again, you see that it's a difference of two squares, which has the squares x square and the perfect square 1. And you can see the subtraction, which represents the difference. So as usual, you say, you copy the numerator the way it is, because there is nothing that we can do. And now, you factorize the denominator, which we are calling the difference of two squares. So you factorize the denominator, where you just duplicate the x's. One x, you write it here, and another one here. Duplicate the ones, one you write it here, and another one here, and make sure that you have a minus and a plus. And once you do this, then you would have factorized the denominator into x minus 1 and the x plus 1. So once you do this, check for the common factor. Check for the common factor between the numerator and the denominator. So as we have seen, we have a common factor which is x minus 1. So you can see we have x minus 1 on the numerator, and we have x minus 1 on the denominator. And because we are multiplying these factors, we are at liberty to cancel between the common factors, which we have noticed. So we can say x minus 1 into x minus 1 is 1, and x minus 1 there is 1. So that we shall proceed as follows. We shall say, so this we get into, on the numerator, we shall have a 1, and on the denominator, we shall remain with x plus 1. So once we remain with this, we can't go any further than this. So we are just supposed to end there. So this is basically how we handle this specific algebraic fraction, where we have the difference of two squares on the numerator or the denominator. Let's look at the last one, C, where we have 2 minus 18p square out of 3p plus 1. Okay, so now, when you compare the two, you will see that the denominator, on the denominator, there is nothing that we can do. But on the numerator, there is something that we can do. And you can see, the way the numerator is not a difference of two squares. As 2 is not a square, and 18 is not a perfect square. 2 is not a perfect square, and 18 is not a perfect square. And confirmation that 2 and 18 are not perfect squares, you get it from trying to get the square root of 2 or the square root of 18. The square root of 18 will give you a decimal number. Similarly, the square root of 2 will give you a decimal number. So these two numbers are not perfect squares. So the way this statement is on the numerator is not a difference of two squares. So when you notice that one, you need to factorize what is common between the two terms. When you see this situation, we need to factorize what is common between the two terms. So as we have seen, what is common between the two terms is 2. You have 2 here, so what is common is 2. So once we notice what is common, we need to take it outside the brackets, which we call factorizing. So we take it outside here, and here we shall remain with 1, then the minus will be maintained, and here we shall remain with 9p square. Okay, then the denominator will also be maintained. Okay, so from there, you see the denominator will be maintained. The denominator will be maintained the way it is. But the numerator, of course, we have the 2 outside here, the 2 outside. Now, when you look at the expression inside the brackets here, you will now see that the expression inside the brackets now is a difference of two squares. You can see 1 is a perfect square, and there's the difference in subtraction, and 9 is a perfect square, and p square is also a square, a perfect square. So this is a difference of 2 squares. So we need to factorize it by saying, obviously we shall have 2 factors. Apart from what we have 2 here, we shall have 2 factors. One of the factors will have a 1 here, and another one will start with a 1 here. Then you can see the square root of 9 is positive or minus 3. So we have minus 3 and positive 3. Then we have p here and another p there. Oh yes. So once we do this, then we would have factorized fully the numerator. And our work now is to see whether we have a common factor between the denominator and the numerator. We see whether we have a common factor between the denominator and the numerator. Okay, as you can see, we have 3p plus 1 as our denominator, and we have 1 plus 3p as our numerator, and you can see that 3p plus 1 and 1 plus 3p are the same, as you have seen. When you are adding or subtracting, when you commute the numbers, that does not make any difference. For example, here you are starting with 3p, here you are starting with 1. But as long as this 3p is positive and this one is positive, this one is positive and this one is positive, then the two are just the same. So you can cancel between 3p plus 1 and get 1, and 1 plus 3p and get 1. So that we shall have 2 outside, 1 minus 3p, then divided by 1, which finally gives us 2 and 1 minus 3p as our final answer. So basically, this is how we handle algebraic fractions where we have the difference of 2 squares. Our work is to just check between the numerator and the denominator and see where we have something to do. For example, we saw that we had something to do on the difference of 2 squares. So thank you very much for your attention.